Welcome to this explainer. Today, we're diving into a real everyday mystery right inside your home. Specifically, we're talking about acids, bases, and salts, testing household solutions using Litmus indicator. Now, you might not realize it, but the cupboards in your kitchen, they're essentially shelves in a fully stocked chemistry lab. I mean, literally, everything from the stuff you cook with to the products you use to scrub the countertops possesses these distinct, really powerful chemical properties. And today, we are going to learn exactly how to categorize those everyday items safely and scientifically, unlocking all that hidden science right inside your house.
Okay, let's actually kick this off by activating our senses, because our bodies actually have their own biological indicators built right in. Think about the liquids you interact with every single day. When you accidentally get a drop of pure vinegar on your tongue, what happens? Your salivary glands instantly kick into overdrive, right? Your face just naturally scrunches up because that sourness is this intense physical reaction. Or think about washing your hands after working outside. When you rub soap between your palms, it creates this very distinct slippery reduction of friction that plain water just doesn't have at all. And if you've ever had to gargle warm salt water for a sore throat, you know the exact undeniable taste that leaves behind. Grounding chemistry in these daily, tangible experiences is honestly the absolute perfect way to start our investigation.
So, to crack this chemical case, here is our 5-step game plan. We'll start with the mystery in your kitchen, then we'll profile our 3 chemical suspects. After that, we'll look at the detective's tool, indicators, before actually investigating some household evidence, and we'll wrap up with everyday science and safety.
All right, section 1, mystery in your kitchen. First things first, we have to set some non-negotiable rules for our lab. Before we begin any testing, we've got to talk about safety. The golden rule of literally any science lab is simple. Do not taste or smell unknown substances. I know, we just talked about the familiar sour taste of vinegar and the saltiness of a throat gargle. But relying on human curiosity, our taste buds or our noses to identify chemicals is incredibly dangerous. Many household chemicals, even just your run-of-the-mill cleaning supplies, are highly toxic or corrosive. Objective science has to completely override our human instinct to sniff or taste. Guessing can lead to serious accidents. So we're going to rely entirely on a rigorous scientific method instead. No exceptions. Moving right along to section 2, the 3 chemical suspects. If we're testing our household solutions, what exact profiles are we actually looking for? Let's meet suspect number 1, the acid. Acids are substances that, when we find them in completely safe food examples, famously trigger that pucker-up, sour reaction we discussed earlier. Think of biting into a fresh lemon or catching a whiff of that sharp tang of vinegar. But, and remember our golden safety rule here, we are absolutely not tasting our test subjects. So the crucial takeaway is their chemical behavior. Acids have this incredibly unique ability to turn a blue strip of litmus paper red. No matter what the acid looks like, what it smells like, or where you found it hiding in the kitchen, if it turns that blue strip red, it has completely given itself away. That color change is its undeniable chemical fingerprint. Next up, suspect number 2, the base. Now, bases have a very different physical profile. In safe household examples like a soap solution or maybe some dilute bleach, they feel characteristically slippery to the touch. And this slippery nature is exactly why bases are so incredibly effective at cutting through tough grease and breaking down oils. They are literally the powerhouses of household cleaning. But chemically, they behave in the exact opposite way to acids. A base will take a red piece of litmus paper and turn it blue. A super helpful little trick to remember this reaction: base starts with B and it turns red litmus blue. Easy, right? And that brings us to suspect number 3, the salt. Now, scientifically speaking, a salt isn't just that basic seasoning you put on your fries. It's actually the fascinating aftermath of a chemical tug of war. You see, salts are formed by a chemical reaction between an acid and a base. When these two opposing extremes mix under the right conditions, they neutralize each other. They effectively cancel out each other's extreme properties, and boom, they form a salt. The most famous example, of course, is the table salt you sprinkle on your food, or a standard saltwater solution. Both of those sit right perfectly in that calm, neutralized territory. So, when we put these 2 primary opposing suspects head-to-head, the contrasts are striking. It's like night and day. On one side, we have acids. They're physically sour, heavily relied upon in food prep for their tang and their preservative qualities, and chemically they turn blue litmus red. On the completely opposite side, we have bases. Physically bitter or slippery, heavily utilized for household cleaning because they dissolve dirt so well, and chemically they turn red litmus blue. Having this direct comparison crystal clear in our minds is absolutely essential before we even think about starting our testing phase. Which brings us nicely to section 3, the detective's tool.
We know our suspects and we know our strict safety rules. So, how do we unmask them safely?
Well, the golden rule we established earlier leads us to a pretty fundamental truth of chemistry. Science testing is safer and honestly far more reliable than tasting. To do this safely, we use what's called an indicator. An indicator is this special material that visibly changes color depending on whether it's introduced to an acidic or a basic solution. It takes human error and all that dangerous guesswork entirely out of the equation. It acts as the ultimate, totally objective lie detector test for the chemicals in your home. Now, this is where it gets absolutely fascinating. Science isn't just confined to these expensive laboratories with high-tech specialized equipment. While standard manufactured litmus paper is the classic indicator used in schools worldwide, nature is actually full of its own chemical indicators. For instance, did you know you can make a highly effective, completely natural scientific indicator right at home using the water from boiled sweet potato leaves? Yeah, commonly known as camotate tops. The natural plant pigments locked inside these everyday leaves react to acids and bases by shifting color, acting nearly identically to the commercial paper. It's a brilliant insight into how accessible real science is. You can literally use local, natural resources to conduct rigorous chemical investigations right on your kitchen counter. No fancy lab coat required.
So let's see how this builds into our actual testing procedure. A good scientist is exceptionally methodical, mostly to prevent any cross-contamination. Here are our 5 strict steps. First, we clearly label clean cups for our samples. We want zero chance of a dangerous mix-up. Second, we carefully place a small amount of our safe household solution into each respective cup. Third, we introduce our detective tool. We either dip the litmus paper or add a few drops of our Comotop liquid. Fourth, we closely observe any resulting color change. And fifth, we accurately record the final result. All right, Section 4, Investigating Household Evidence. It is finally time to look at the data from our kitchen laboratory tests and analyze what our indicators have revealed.
Let's narrate our findings chronologically here, starting with our Part 1 results. When we tested our first sample, vinegar, we already knew its common physical property was sour. But here's the science part. When we dipped the blue litmus paper into the cup, the paper immediately shifted to red. Therefore, we can scientifically and safely classify vinegar as an acid without a single risky taste test. Moving over to our second sample, the soap solution, we noted its slippery feel. We dipped the red litmus paper in, and it turned a distinct blue. This objective color change confirms, without a shadow of a doubt, that our soap solution is a base. Continuing our investigation into Part 2, we looked at calamansi juice. And guess what? It yielded the exact same red flag result as the vinegar. It shifted the blue paper to red, firmly classifying it as an acid. Then we tested our baking soda solution, which is a renowned powerhouse for tough household cleaning, and it successfully turned the red litmus blue, proving it's an alkaline base. But our third test subject is incredibly important: salt water. It physically tastes salty, but when we introduced the indicator, the paper remained completely neutral. It didn't push toward the acidic red, and it didn't push toward the basic blue. It acts as the perfect control in our experiment, neatly fitting the profile of a neutralized salt. The scientific method just works flawlessly. And finally, we reach Section 5, Everyday Science and Safety. Because let's be honest, why does categorizing baking soda and vinegar actually matter to you outside of a fun little experiment? Well, it matters deeply because this underlying chemistry practically governs your daily life. Understanding acids and bases is crucial for cooking and food prep. For example, acids act as incredible natural preservatives, and knowing how ingredients will chemically react can entirely make or break a texture of a baked recipe. It's also absolutely essential for cleaning and hygiene. You now understand exactly why those slippery basic solutions are required to break down stubborn lipids and grease on your stove. But most importantly, it empowers the safe handling of materials. When you truly understand these properties, reading product labels becomes a tool for survival and ensures you never accidentally mix opposing highly reactive chemicals during your daily chores or your livelihood activities. And you know, the values of a good scientist translate perfectly into being a highly responsible member of a household. Being meticulous and careful with samples in a lab environment is conceptually no different than safely storing abrasive cleaning chemicals way out of reach, far away from your pantry at home. Honesty in recording an indicator's color change translates directly to a deep respect for evidence, like, say, not ignoring a glaring hazard warning label just to save 5 minutes of time. Ultimately, applying these structured scientific principles shows a genuine, proactive concern for your family's health and safety. You learn to respect the boundaries of these materials. Which leaves us with one final thought to ponder today. We've successfully unmasked the chemical suspects sitting quietly on your shelves. We've proven that with just a simple strip of litmus paper, or even the amazing natural pigments of sweet potato leaves, you can unlock the complex science hidden right there in your kitchen. So, armed with this new, profound understanding of how acids, bases, and salts interact right behind the scenes, how will you approach the chemical products sitting in your own cupboards today to ensure your home is both wonderfully curious and perfectly safe? Thank you so much for joining me on this explainer, and as always, stay curious.